Hi, my name is Mohammed Mourabit. I'm a graduate student at University of Texas at Arlington in the Department of Physics, and it would be my pleasure to present to you some of the work I have done with Dr. Weinberg on resonant mode coupling in delta Scuti stars. So delta Scuti stars are a type of variable stars that live on or near the instability strip and exhibit brightness fluctuation that follow a period luminosity relationship. The brightness fluctuation is due to unstable excited fluid wave that we call oscillation modes in the field of astroseismology. And in particular, the Kepler Space Telescope has observed 1,000 of these delta Scuti stars, for which over half of exhibit large amplitude modulation. It has been proposed that these large amplitude modulation can be explained by a type of nonlinear mechanism called nonlinear three-mode coupling. And this has pushed us to carry an analysis on delta Scuti models in which we compute the coupling strength of triplets within these models to see if they're large enough to expect them to be observable on the spectra. We have found many of these triplets exhibit a large magnitude of the coupling strength mu. And therefore, we started by constructing 14 delta Scuti models with 4 different masses. So these are the mass tracks in different colors, red, green, blue, and orange. Our models are the 14 models that are the black triangle on these tracks. The points in the back are the observed delta Scuti, and the lines that limit the classical instability strip region where which these delta Scuti live. So from these models, we get the key quantities that we needed to compute the oscillation modes using gyre. So we considered both P modes, which are modes for which the primarily restoring force is due to pressure, and G modes, which are modes for which the primarily restoring force is due to gravity or buoyancy. Here on the left, we actually have the radial displacement of a P mode as a function of radius, and on the right, the radial displacement of a G mode as a function of radius. For each of these modes, we calculate their radiative and turbulent damping terms that we will need for our analysis, and we carry on the nonlinear analysis. So here we investigate a nonlinear coupling between two parent modes that have been linearly driven to a high amplitude that it will interact with each other to excite a third daughter mode. And we consider 10 to the 4 unique combinations of these mode triplets, parents and daughters, in each of our model. And for each triplet, we calculate the coupling strength mu, which depends on the detuning, which is how the 3 frequencies in the triplet combine, the damping rate of the daughter, as well as the nonlinear coupling coefficient kappa IBC. The amplitudes of the modes in the triplets follow this relationship in the bottom of the screen, where the daughter's amplitude is proportional to the product of the parent's amplitude, therefore nonlinear. For our results, we have found that for each of our model, we found many triplet combinations, which are delimited by these points here, for which their coupling strength mu is very large, over 1,000, 10,000, and even sometimes over 10 to the 5. The arrow here on the left side of the plot represents the range of observed delta Scuti mu's, and obviously the points are results. And we have plotted these coupling strengths as a function of the kappa ABC and the detuning, 2 important parameters when calculating mu's. These results have shown that nonlinear mode coupling could be and should be a observational feature in delta Scuti spectra. We have seen this result for all of our models, and they're broadly consistent with the observations from Berger and Montgomery in the Kepler observations. In future work, we plan on creating more models and compare them to ongoing observation with the TESS telescope, which is observing many delta Scuti stars as well. And we also plan to model large networks of nonlinearly coupled modes, parents and daughters, through generation and solve the amplitude equations, as well as modeling the driving mechanism of the parent, which is the kappa mechanism in delta Scuti stars. And if you're interested in learning more on this, we have a paper on the archive that you can read if you want. And if you have any questions, please reach out to me. And thank you very much for listening to my presentation. I hope you enjoyed the rest of UTA Discovery Symposium 2023.